Okay, we're continuing with volume of solid of rotation, and right now we're looking at rotation about the y-axis. Now, the volume V of the solid formed when the curve y is equal to f of x is rotated once about the y-axis between y is equal to c and y is equal to d is given as d is equal to pi, the integral from c to d of x squared, and you're integrating with respect to y. All right, so I'm going to take a minute to show you how such a formula could have come about. All right, in the diagram below, what we have is a curve, and we have an area between the curve and the y-axis. That area is between y is equal to c and y is equal to d. So what I did is I'm going to take a strip, just a small strip in that area, and the strip is so small so that it approximates a rectangle. Now, if I rotate this strip about the y-axis, I'm going to get a solid is going to be generated, which would look probably something like this. All right. Now, this solid would approximate a cylinder. All right. So the y-axis is the y-axis, and this solid approximates the cylinder. The length here is still x. Now, x now becomes the radius of the cylinder, and del y becomes the thickness or height of the cylinder. Now, the volume of the solid that is generated, V, would be equal to A times H. Of course, the volume of all solid shape with a uniform cross-section. A cylinder is a solid shape with a uniform cross-section. Is given by the formula V is equal to A times H, where A is the area of uniform cross-section. So that uniform cross-section is a circle. So that's pi r square h. Now, the radius of the cylinder that is generated is x, and the thickness or height is delta y. So the volume V is actually equal to pi x squared delta y. So that would be the volume for the what? Just a little strip that is rotated once or 360 degrees about the y-axis. Now, the entire volume V would be given by the formula pi, the integral from c to d of x squared, and of course, I'm integrating with respect to y. All right. So this is how a formula like this could come about. How they got this formula. All right. So let's use it. It says find the volume of the solid of revolution formed by rotating the area enclosed by the curve y is equal to 2x squared minus 3. The y-axis, the line y is equal to 0, y is equal to 2 through 360 degrees about the y-axis. All right, we already established that that volume V would be equal to pi. The integral from y is equal to 0 to y is equal to 2 of x squared, and I'm integrating with respect to y. Now, y is equal to 2x squared minus 3. And what we're interested in is y in terms x squared in terms of y. So I'm going to have 2x squared is equal to y plus 3. Negative 3 goes over and becomes positive. Then I'm going to divide the entire equation by 2. I'm going to have x squared is equal to y plus 3 over 2. All right, so therefore, the volume of the solid of revolution is equal to pi, the integral from 0 to 2 of x squared, and of course x squared is equal to y plus 3 divided by 2, and I'm integrating this with respect to y. Let's pull the 2 out. So this would be equal to pi over 2, the integral from 0 to 2 of y plus 3, which I'm integrating with respect to y. If I integrate y, I'm going to get y squared divided by the new power, which is 2. And if I integrate 3 with respect to y, I'm going to get 3y. And the limits are y is equal to 0 and y is equal to 2. First, I'm going to replace y with 2. So this is pi over 2. So next I'm going to have 2 squared over 2 plus 3 times 2 minus, then I'm going to replace y with 0. 0 squared over 2 plus 3 times 0. And no matter what you do with that, you'll always get back 0. So the entire right side is gone. And what we're left with is 2 squared is 4, divided by 2 is 2, and 3 times 2 is 6. So this is a total of saying pi over 2 multiplied by 8. 4 divided by 2 is 2, 3 times 2 is 6, 2 plus 6 is 8. And so our final answer is 4 pi cubic units. All right, let's go again. Example 23. It says, find the volume of the solid of revolution formed by rotating the area enclosed by the curve y is equal to 3 over x, the y-axis, the y-axis, the line y is equal to 2, y is equal to 3, through 360 degrees about the y-axis. So we are rotating something about the y-axis, so the volume v is equal to pi, the integral from x is equal to 2 to x is equal to 3 of x squared dy. Y is equal to 3 over x. All right. If I have one fraction is equal to one fraction, I'm going to cross multiply. Therefore, xy is equal to 3 times 1, which is 3. Divide both sides by x by y. And I'm going to get x is equal to 3 over y. Now, therefore, x squared, which I need for the calculation, would be equal to 9 over y squared. And so the volume that I'm seeking, the volume of the solid of revolution, V, is equal to pi from y is equal to 2 to y is equal to 3 of x squared, which is 9y to the minus 2, and I'm integrating with respect to y. Let's pull the 9 out. I'm going to end up with 9 pi. Let's integrate this. I'm going to increase the power by 1. It's going to become minus 1. So it's y to the minus 1 divided by the new power, which is minus 1. And so this is from 2 to 3. So this becomes 9 pi. And over here, I'm going to have minus 1 over 3 minus a minus 1 over 2. So now I'm going to get 9 pi, and this is going to be a half minus 1/3. So this is equal to 9 pi, And a half is the same as saying 3 over 6 minus 2 over 6. And so that is 1 over 6. So this becomes 9 pi multiplied by 1 over 6. 3 into this is 2. 3 into this is 3. Our final answer is 3 over 2 pi cubic units. Let's go again. Example 24. Example 24 says, find the volume of the solid of revolution formed by rotating the area enclosed by the curve y is equal to 3x squared plus 2. The y-axis, the lines y is equal to 2, y is equal to 5 through 360 degrees about the y-axis. Again, this volume V would be equal to pi, the integral from 2 to 5 of x squared dy. Again, we have y is equal to 3x squared plus 2, and so we'll need x squared in terms of y. We're going to have that 3x squared is equal to y minus 2, divide both sides by 3, and we have x squared is equal to y minus 2 over 3. So our volume V would be equal to pi, the integral from 2 to 5 of x squared, which is y minus 2 over 3, and we're integrating with respect to y. Let's pull out that 3. We have pi, the integral pi over 3, y minus 2, and we are integrating with respect to y. So now we have pi over 3. When we integrate, we're going to get y squared over 2 minus 2y, and the limits are 2 to 5. So 2 here, 5 here. Next, we're going to replace y with 5 and then y with 2. We have pi over 3, and we have 5 squared over 2 minus 2 times 5 minus 2 squared over 2 minus 2 times 2. All right, and let's try and work this out quickly. This is pi over 3. We have 25 over 2 minus 10. Over here we have 4 over 2 minus 4. All right, now 2 divided by 4 is 2. 2 minus 4 is 2. So we have over here, we have pi over 3. On the left-hand side, we have 25 over 2 minus 20 over 2. On the right-hand side, we have minus 2. All right, and so now we have pi over 3. This is 5 over 2 plus 2. So that is 4 over 2. That's 9 over 2. Now I have pi over 3 times 9 over 2. Our final answer is 3 over 2 pi cubic units. All right.